In this video, we're going to look at what is probably one of the most complex revolves in the National 5 question papers. We're going to use Autodesk Inventor to model it, and in order to do that, we have to do a bit of problem solving. What this shape is a little bottle top, and what it has is this cut sloping surface. In order to model this, we actually have to ignore that this sloping surface is here, and we are going to do a revolve because it is cylindrical. The only thing that doesn't keep it from being symmetrical is that it has this slope coming down it. We want to pretend the slope isn't there, and we're going to treat it as if it has a flat surface. We're also, to start off, going to model it without it being hollow, because this speeds up the process and it means we can use shell later on. To start off, we're going to go for the approximate outline shape, and we're going to follow it along with the mouse cursor around the outside, along to the right and down again. What we can then do is we can add our sizes, which involves these different diameters, which we'll come back and check along as we go, and these various heights. Our starting point is a new file. Click in metric, millimeter IPT, click and create, starting a sketch, choosing the front plane and choosing XY. And then what we're going to do is we're going to use the line tool. We're going to create a centre line, starting from the middle, moving up to a good height, right click, OK, and then turn off centre line. Then we can use the line tool to approximately sketch out the shape of this object. Making sure that you return the top to the bottom as well, and click OK. We go back and just double check we've got the right kind of profile shape. You can see we've got a slope, cuts across, slope, cuts in and goes down vertically. So let's add in our heights. Our overall height is 63, so we'll add that in first, and then we'll add the 40 and the 20. Dimension from the top to the very bottom line, and add that in as 63. Then starting from here to the next horizontal down, and set that as 40, and select from here to here as being 20, leaving our small section at the bottom. The next thing we're going to do is we're just going to dimension this vertical line on its own, so not going from left to right, because then what we can do is we can add in the 38 that we're given. You can see that this line here has jumped in slightly, which means that we've not got this sloping line anymore, but when we add in our other sizes, it should correct it for us. The next diameter that we're interested in is the distance from this little point all the way across, going from here all the way across to there. It's given as 61. We're going to remember to click from this little point and then to the centre line, and it'll allow us to add that dimension. So taking that dimension from this point and then clicking our centre line and setting that as 61, you can see it's moved that size in. Now, it's stepped this part in to the wrong way, so what we're able to do is if we drag this line just by zooming in and clicking and holding, it can move, and if we click and drag this one, you can see it gets it more into the right shape. That's a really handy tip and trick to have, just in case you do find sizes move about. We'll go back and now we'll look for the diameter for here and for here. You can see we've got one given as 48 and one given as 28. So dimension from here into the centre line, can add that as 28, and then what we'll do is we'll add that next one in there to get our size from here to here, given us 48. And now what you can see is we've got approximately the shape that we need. Once we've finished that sketch, we can go and use the revolve command. You can see it now gives us roughly the shape that we were after. It's going through 360 degrees, and we click OK. Now at this point, you can see it's missing that sloping surface. So how do we add that in? Well, because it's a curved surface, we can't sketch automatically onto the curved surface. It wouldn't give us the right geometry and it would be incredibly difficult to work out. What we then have to do is use the work plane options. Now, to view your work planes, your original work planes, if you click the plus beside your origin folder, you'll see your YZ, your XZ and your XY planes. If we turn this into an isometric view, you can see that the XY plane cuts all the way through the centre. The XZ sits on the bottom and the YZ cuts through the centre in the opposite direction. Provided you've started your sketch, snap to the centre origin, so that's that little green dot in your screen when you're in sketch mode, your work planes will always be in the middle. If you find that you can't get your work planes to be in the middle, then that's where we might need to use things like the offset plane or the mid plane to help us out, or even the little tangent. Fortunately, our XY plane is in the middle. We're going to right click on the little XY plane icon and make the visible icon come on. We're going to start with a sketch on the XY plane, and what we're going to do is we're going to sketch the profile we want to remove. We're going to sketch the shape that we want to be taken away from the top of this. To make this a little bit easier, we're going to go into view and we're going to change our visual style just to be wireframe with hidden edges. It basically makes our object see-through. I'll go back into sketch mode, and what I'm going to do is I'm going to draw a little triangular wedge that starts 30mm up from this line here, goes right to the corner at X and joins back across. To do that, I use the line tool, click so it goes green, and click to the other side, move down to somewhere down this line and snap to it, and then go from here up to the corner and snap again. And what that does is it gives us a little triangle here. To get the size, I dimension from that corner there to the bottom here, and I input that as 30, and I finish the sketch. Now what you can see is I have a little triangle midway through my object. If I now go to view and change back my visual style to shaded, I can't see the sketch, but it still exists over here, and if I was to click on that line, I can tell that it exists there as well. In 3D model mode, I go to extrude, I select the little triangle, and then what I do is I change it from being a join or an addition, and I change it to a cut, which we would call a subtraction. I choose to cut it out or subtract it. I choose the direction to be symmetrical, and then what I want to do is I want to make sure that it doesn't just have a distance, that it goes through everything, it goes through all. I could also just change that size to be as big as the original diameter of the object. Now when I spin that side on, you can see that it's starting to subtract out and remove that object. If I click OK, it's removed that surface, and what I'm able to do is then go back into my origin folder, right click on the XY plane and turn the visibility off. I can even shrink that folder down. The last stage is then to hollow out the object and remove the material from inside. We can do this using the shell command. I want to remove that bottom face, and then I just need to check what my wall thickness is. On this drawing, further down it tells us that the wall thickness is 3mm, which means the thickness of the material is 3mm all the way around. So I change that thickness to be 3, making sure I've selected to remove that bottom face, and I click OK. That's now hollowed out the object and I can see inside it. It's really important that the shell is carried out after the extrusion, because had I moved the shell to before it, you can see that what would happen is that cut would then remove the surface and it would turn it into an open object, which is obviously not what it's meant to be. So what I've done is I've used the model tree to be able to drag the shell back into position just by clicking and dragging. And again, that's a really handy tip to be able to check out just in case you've maybe modelled something in the wrong order.